Welcome back to my channel. Let's solve third question of weekly context 487, design ride sharing system. Okay, a ride sharing system manages ride requests from riders and availability from riders. Riders request rides, driver becomes available over the time. The system should match riders and drivers in the order they arrive. Okay, so what they are trying to say is whenever a particular rider and driver are available, we should basically uh, allocate them in the order in which they arrive. Okay, so let's also go through the complete problem statement. Implement the ride sharing system class. Ride sharing system initializes the system. Void add rider will adds new rider, okay, with a given rider id. Add driver will basically add driver to the system. These are the key functionalities which we have to look into. One is match driver with the rider and one other is to cancel rider. Okay, match the earliest available driver with the earliest waiting rider and remove both of them from the system. Okay, so let me give an example. Okay, so initially let's assume that we have drivers and then we have riders. Initially both are empty. Okay, now let's say a driver got entered into the system and rider was also entered into the system. Okay, now when we try to match, okay, let's also consider few more things. Okay, let's say driver 2 has also entered into the system and rider 2 has also entered into the system. Okay, now whenever we are trying to match driver with the rider, we have to make sure that the first rider which has entered into the system should be matched with the first driver which has entered into the system. So both will be matched and both will be removed from the system, and we will be basically returning in the format of driver id comma rider id. Okay, now next time when we match it, both two, first time when we match 1 and 1 got popped out, and next time 2 and 2 will be popped out. Now that there are no riders and no drivers which needs to match, now if you are trying to match in this case, then we have to return -1 comma -1. Okay, when there is a rider available, okay, and when there is a driver available and there are no riders to match, or when there is a rider available and there is no driver to match, or both are not available, in all these three scenarios we have to return -1 comma -1. Okay, and when we are trying to cancel the ride, okay, let's say there are list of riders available, let's say 2 3 4 other riders available, and let's say rider 3 wants to cancel, so we will basically remove the rider from our system. So in the future we won't be allocating any drivers to the rider 3. Okay, if you see, we should be able to remove a particular rider from our system, so the rider can present in any place. Okay, so if you see, the matching functionality is happening in terms of FIFO ability. Okay, whoever the rider which comes first will be allocated to the driver who comes first. Okay, so we want a data structure which helps us to determine the first in first out, and we should also able to delete a particular element in constant time. Okay, so if you want to delete this particular rider, one approach is to scan the entire riders and then delete this one particular element, or else is there any better we can do? Okay, so if we use doubly linked list, then we can effectively delete this rider by using some extra space. Okay, where we will be keeping a hash map which will keep track of, okay, let's say we have a map which will keep track of rider id and its corresponding address to the node. Okay, and so on and so forth. Okay, this way we can identify which node I have to delete, and then once I know which node I have to delete, in the doubly linked list we can delete a particular node in a constant time. We just have to point this node to its this, and this node we have to point it to this, right? So the drivers are, we cannot delete a driver, right? There is no option to delete a driver. So driver has only one functionality which should have the ability of FIFO. So for drivers, we can have a queue, whereas for rider it has two abilities. Okay, ability to element based on the rider id, and we should also has the ability to have a FIFO. Okay, first in first out. So DDL doubly linked list with hash map will help us to achieve this functionality in constant time. Okay, adding a rider will also take a constant time, because every time we add a new rider we'll be adding at the end, which will also take a constant time. Adding a driver to a queue will also take a constant time, because we are adding at the end of the queue. So both the operations will take constant time only, and matching a rider will also take a constant time. Cancelling a ride will also take a constant time. If you see, we have optimized all our operations. Now let's see how we can implement it. As I mentioned, we required a doubly linked list to store the driver, so I have defined a variable called driver queue, which will be which will just act like a queue. Okay, we need a queue to process drivers, and we need a doubly linked list. Okay, doubly linked list has headers and head and tail, right? So in order to store a particular rider information, I have created a class saying that rider node, which will have a rider ID and a pointer to its previous as well as its next. Okay, I just defined a constructor which will take a ID and then map it to the field. Okay, now that I have a head and tail, I also require a hash map to efficiently identify the address of a particular rider. So I have this hash map in place. Okay, so whenever I'm instantiating my system, so I've placed a dummy nodes head and tail. So initially my doubly linked list will contain two nodes. Okay, with -1, which will be pointing to -1. Okay, so I have a doubly linked list with head as this, head pointing to this node and tail pointing to this node. Okay, now we only require whenever we are adding a rider, we should be adding at the end. That means we need a functionality to insert a tail, so where I will be taking a rider id and then I will be creating a new node. Okay, and then I'm just mapping the pointers accordingly, and I should also make sure I'm having the particular rider information in hash map. Okay, I'm mapping the rider id with the node which we have created. This will help us to determine where exactly a particular rider node is available. Okay, which will be handy for the deletion process. Okay, so now let's look at add rider. Okay, so whenever we are adding rider, we should be basically adding the riders at the tail of our doubly linked list, and we should also insert them into our map. Okay, which we are doing in the insert function itself. The next functionality is about add driver. So drivers, whenever we are adding a new driver, we should simply add it into our queue, which is driver queue, which we have defined over here. We will be just offering the driver id into our driver queue. Now comes the main functionality, matching a rider. Okay, if my riders are not available, or if drivers are not available, then I will be returning -1 comma -1. Okay, now if both are available, that means I have to first get the driver id and I should also get the rider id, right? So rider can be determined, so I should get the initial element, right? So the initial rider would be next to our head, right? Because we have a dummy node at the head which is -1, we should take the next element of our head. Okay, that will give our rider node. Now that I got the rider node, since I'm allocating driver with a rider, I should delete the rider from our system, and since we are polling the driver, we are also removing the driver from our system. Okay, in the end I should return driver id and rider id. So how does the remove function basically look like? Okay, let's go and check out the remove function. Okay, what does the remove function does is it's going to remove a particular node from our doubly linked list, and it will also delete the node from our hash map as well, because it should be mapped in the both the places. Okay, so what I was doing is I'm just taking the previous node of the current node, I took the next node of the current node, and then I've just updated my pointers. Okay, now that my match driver with rider functionality is also done, now my responsibility is to cancel a ride. Okay, whenever I'm trying to cancel a ride, I have to first check whether this rider is available in our system or not. If the rider is available in our system, then I will simply remove the rider from our system. That's it. Okay, if we submit this problem, as you can see, all the test cases were passed, and also it is pretty efficient because all the functionalities which we have implemented will only take constant time. Okay, and we are using an extra space also for the hash map where we are storing all the driver information. Okay, this will, as the number of riders increases, this will also take a complexity of order of n. Okay, that's all about this problem. If you like the explanation, hit the like button and also subscribe to my coding channel so that you will be missing the content which I will be posting on daily basis. And thank you.